All right, guys, we're going to go ahead and go over our notes for Learning Goal B, planets in our solar system. Our learning goal here is to describe the defining characteristics of each of the major planets in our solar system. So let's go ahead and start with the inner planets. We talked a little bit about these in our last learning goal. These are our 4 terrestrial planets that are closest to the sun: Mercury, Venus, Earth, and Mars. They're similar to Earth. They're solid, dense, and rocky. None of the inner planets have rings. Compared to the outer planets, they are small, but that's comparatively. And they have shorter orbits around the sun and spin more slowly. Our first one is Mercury. Mercury, we need to edit that, but Mercury has a rotation that lasts almost 60 days and a revolution that lasts 88 days. So that means a day on Mercury is 58 or close to 60 days, and a year is 88 days. They don't have any moons. The temperatures can reach 430 to negative 170 degrees Celsius. It's the smallest planet. Its surface is rocky and mostly iron. It has no atmosphere or water. Our next planet is Venus, my favorite planet. I love this because the rotation is actually longer than the revolution. So that means a day is longer than a year. It has 0 moons. It's the hottest planet because of their thick atmosphere that's over 90% carbon dioxide. And it actually rotates east to west, which is different than a lot of other planets. Earth, our beautiful home planet, it has a rotation of 24 hours. That's how long our day is. And the revolution is 365. So that means that it takes 365 days to go around the sun. That's why we have 365 days in a year. We have 1 moon. Love our moon. We're about 70% water, which is really unique. We have an atmosphere of 20% oxygen. The greenhouse effect is what keeps us warm, like a little blanket, and not burning on fire like Venus. And the gravity that we have can hold gases. Mars is our last terrestrial planet, last inner planet. The rotation is a little bit over a day. And when we say days on these, we're talking about Earth days. So it's a little bit longer than ours, and the revolution is much longer. So, or not much longer. It's very similar to Earth as well. It has 2 moons. It's the red planet because of its iron rocks. There's the temperatures there. It has ice caps at the top and the bottom. It has a thin atmosphere of 95% CO2. Okay. We have the outer planets. So this is Jupiter, Saturn, Uranus, and Neptune. These are much, much larger. They're mostly made out of gases. They're called the gas giants, mostly made out of hydrogen and helium, have a lot of moons. Some have rings made out of dust particles, and Saturn has the only rings that you can actually see from Earth. Jupiter has a rotation of 9.9 hours, so it's much faster than a day on Earth. The revolution is much longer. Okay, so their revolution takes 11 years, or versus ours, which takes 365 days. They have 63 plus moons, crazy amount of moons. They have a giant red spot, which is like a hurricane that's bigger than Earth, so it's just like a raging storm. It's the largest planet, and its atmosphere is made up of hydrogen and helium. Saturn has a rotation of almost 60 hours, a revolution of 88 years. Its rings are made of ice and rock and dust particles. It has more than 61 moons. My favorite moon is on Saturn. It's Titan's moon. It's so cool. The atmosphere is hydrogen and helium, and it's super cool. I just love Saturn. It's awesome. Look up the moon of Titan. Okay, Uranus has a rotation of 17 hours and a revolution of about 84 years. It has 27 moons. It has this blue-green color because of the methane there. It's like a milky blue. It has rings that tilt with the axis. The axis is 90 degrees, and it spins from top to bottom instead of side to side. And then our last planet, Neptune, this has a rotation of 16 hours. So a little bit more than half a day here. And its revolution is 163.8 years. It has a lot of methane in the atmosphere. Again, it gives it that blue color. It has 13 moons, visible clouds, lots of storms raging on Neptune all the time. It's the furthest from the sun, and that dark spot on it is a storm, much like Jupiter's storm. Of course, we have our dwarf planets, but we don't have a slide for those. That would take a long time to go over all of those, but those